In this lecture, we will derivation of Schrodinger wave equation and also learn it for hydrogen atom. Let's start now. Derivation of Schrodinger wave equation. Derivation of Schrodinger. Derivation of Schrodinger wave equation. The equation for a standing wave of wavelength lambda. Wavelength equal to lambda. Wavelength lambda, whose amplitude at any point along x may be given by a function fx. Function fx is follows: del square fx upon del x square equal to minus 4 pi square upon lambda square fx. When an electron is considered as a wave which moves in x direction only, then the function wave equation is as del square psi upon del x square equal to minus 4 pi square lambda square fx. When an electron is considered as a wave which moves in x direction only, then fundamental wave equation is del square psi upon del x square equal to minus 4 pi square upon lambda square equal into fx. Then 1 upon lambda square equal to del square psi upon del x square 1 into 1 upon 4 pi square psi. 1 upon 4 pi square psi. Where lambda is wavelength, psi wave amplitude. Lambda wavelength. And psi is wave amplitude. And x displacement, and small x equal to displacement along x direction. According to de Broglie equation. Wait just 1 minute. According to de Broglie equation, lambda equal to h upon mv. 1 upon lambda square equal to m square nu square upon h square. This is equation number 2 from equation 1 and 2. Equation number 1 from equation 1 and 2. M square nu square upon h square equal to minus del square psi upon del x square. Point 1 into 1 upon 4 pi square psi. Then m square v square equal to h square upon 2 pi square psi into del square psi upon del x square. This is the equation number 3. Since potential energy for any particle Ke equal to 1 upon 2 mv square, then Ke equal to m square v square upon 2m. Multiply this equation is multiplied by m in numerator and denominator. Then m square v square equal to Ke into 2m, Ke into 2m, Ke into 2m. From this is the equation number 4. This is the equation number 4. From equation number 3 and equation number 4. From equation number 3 and equation number 4, Ke into 2m equal to minus h square upon 4 pi square psi into del square psi upon del x square. Then Ke equal to minus h square upon 8 pi square psi into m into del square psi upon del x square. Total energy E. Total energy capital E equal to kinetic energy. Which energy? Kinetic energy plus potential energy. Kinetic energy plus potential energy. Kinetic energy plus potential energy. Then h square upon 8 pi square psi m into del square psi upon del x square plus E minus Pe equal to 0. This is the equation number 5. Dividing equation 5. Dividing equation 5. Equation 5 by h square upon 8 pi square psi into m. Then this value is del square psi upon del x square plus h pi square m psi upon h square into E minus 8 pi square m psi upon h square into P potential energy equal to 0. Sorry, this is del square psi upon del x square plus del square m psi upon h square into E minus 8 pi square m psi into h square into P equal to 0. Then the value is del square psi upon del x square plus h pi square m upon h square E minus P into psi equal to 0. Then del square psi upon del x square plus h pi square m upon h square into E minus B into psi equal to 0, where Pe equal to B. This is the equation number 6. Equation number 6 represents Schrodinger wave equation in x direction. Hence, Schrodinger wave equation for atomic system in 3 dimensions x, y, z may be written as del square psi upon del x square plus del square psi upon del y square plus del square psi upon del z square plus 8 pi square m upon h square E minus B into psi equal to 0. This is the equation number 7. Then del square psi plus 8 pi square m upon h square in bracket E minus B into psi equal to 0. This is the equation number 8. Del square equal to Laplacian operator. Del square upon del x square plus del square upon del y square plus del square upon del z square. The solution of Schrodinger order differential equation gives the electron distribution in space as well as lowest energy levels of an electron. The value of psi square for an electron at any given point will give the probability of finding the electron at that point. Hence, Schrodinger wave equation is a note of wave mechanics and is based on the idea of the electron as a standing wave around the nucleus. Erwin Schrodinger was awarded Nobel Prize for this equation. Ion value and ion function. You wait just of 1 minute. And Schrodinger wave equation for H atom. Schrodinger wave equation for H atom. In case of H atom, since a single electron of charge E is revolving around the nucleus. In case of hydrogen atom, a single electron of charge E is revolving around the nucleus of charge plus E. The potential energy PE is equal to minus E square upon R. Thus, and putting PE equal to minus E square R in Schrodinger wave equation, then we get del square psi upon del x square plus del square psi upon del y square plus del square psi upon del z square plus 8 pi square m upon h square in bracket E plus small e square upon r into psi equal to 0. This is the Schrodinger wave equation for H atom. This is the Schrodinger wave equation for H atom. Okay, thank you.